In example 18.11, we looked at the compound interest formula for a finite number of compounds. That would be annually, semi-annually, quarterly, so on. And those had a finite number attached to them, like 1, 2, 4, monthly was 12, daily was 365. But there is another way that this can be done, where we have what's called continuously compounded interest. So with continuously compounded interest, this is the notion that n is approaching infinity in that formula. Now, when we allow n to approach infinity for that formula in definition 18.4, it gives us a new version of the formula called the PERT formula, and it's A equals P times e raised to the RT. So the same things are here that we saw with the compound interest formula, except we don't have to worry about n this time, because this automatically takes into account the fact that n needs to approach infinity. So the P is still the principal amount, R is your interest rate per year in decimal form, T is the number of years, and then A will represent the amount after T years. For example, 18.12, I want to do the exact same setup where we have $1,000 being invested, the interest rate is 12% per year, and the time is going to be 3 years. The only thing that's different is that it's going to be compounded continuously. So again, compounding continuously means that we have n approaching infinity, and it won't be possible to plug infinity into that formula for compound interest because it's not a real number. So we have to use this other formula, and it's going to say A equals 1,000 times e raised to the 0.12 times 3. So in other words, 1,000 times e raised to the 0.36. And you should be able to type this into the calculator and get yourself an answer. The amount is going to be $1,433.32. And that is slightly better than what we had for the 365-day compounding schedule. And this would be the maximum possible outcome that we could get using these particular circumstances.